A. What is the terminal voltage of a large 1.54 volt carbon zinc dry cell used in physics lab to supply 2.00 amp to a circuit if the cell's internal resistance is 0.100 ohm? Alright, given the electromotive force, which is 1.54, that is the voltage of the source, and it has internal resistance of 0.100 ohm, and there is current of 2.00 amp in the circuit. And A is asking what the terminal voltage is. Alright, so if we represent this in schematic diagram as follows, we have the carbon zinc dry cell, and it has internal resistance, and this will be the output. The terminal voltage is what we are required to find. This is the internal resistance, this is the electromotive force. So the dry cell is this one here. The dotted line represents the dry cell. R is the internal resistance. Therefore, there is current. That current is flowing in this direction. Alright, so the voltage at the terminal is going to be the source's voltage, which is E, minus the voltage dropped due to the internal resistance, and that's going to be I times R. Current multiplied by the internal resistance. So the voltage is going to be 1.54 volt minus 2.00 amp multiplied by the internal resistance, which is 0.100 ohm. The terminal voltage will be 1.34 volts. B. How much electrical power does the cell produce? Let us to find what is the total power produced. Total power is the source voltage multiplied by the current. And that's 1.54 volts multiplied by 2.00 amp. And that's equal to 3.08 watts. And see what power goes to its load. So power of the load is required. And the power of the load is basically its total power minus the power dissipated by the internal resistance. So PL is going to be total power minus power dissipated by the internal resistance. Power of the load is equal to total power, sorry, this is going to be total power minus power dropped by the internal resistance, which is I squared R. So power as a load is going to be, we have calculated the total power in B, and that's 3.08 watts. Minus the current squared, which is 2.00 amp squared, times the internal resistance, which is given to be 0.100 amp ohm. That will be equal to 2.68.